Consider two sets, cap x, which we'll call the domain space, and cap y, the range space. We may think of a function, f, as mapping any given point or pre-image, x into its unique image, y in the range. Then we write y equals f of x and say that x is mapped into f of x. Since pre-images are paired with unique images, we define a function as any set of ordered pairs, no two of which have the same first element. This means that the ordered pair, xy, is an element of the function f if and only if y equals f of x. The domain of the function then consists of all points within the domain space which are pre-images. And the range of the function is simply all points in the range space which are images. We can visualize this better when we consider the special but fundamental case of functions which have the real number line r as both domain space and range space. These we'll call functions from R to R. Then if f is an R to R function, it maps a real number, x, in the domain into its image, f of x, which is also a real number. The simplest R to R functions are the constant functions, which map every real number into a single prescribed real number. The constant function, say k sub c, maps every number x into c. So the range of k sub c is a single point. Also, any interval on the domain shrinks to the single point, c, in the range space. For example, k sub 3 maps every number into the number 3. So the range of k sub 3 is just that single point. Similarly, k sub minus 2 sends every number and every interval into the image minus 2. The identity function I maps every number into itself, so that I of x is simply x. Of course, every interval is mapped into itself as well. Translation functions shift pre-images right or left by a constant amount. Thus, t sub c maps the domain origin into the translation constant c, and maps every point x into the point x plus c. Translation functions preserve distances. That is, any two images must be exactly as far apart as their pre-images. For example, t sub 5 maps the origin into 5 and every number x into x plus 5. Every image is the result of translating its pre-image 5 units to the right. For t sub minus 4, the origin maps into minus 4, and the pre-images plot in 4 units to the left. Magnification diagrams resemble light rays from a point source. Every image is obtained by multiplying its pre-image by a real number, c, called the magnification coefficient. Thus, m sub c maps the origin into itself, the point 1 into c, and every point x into c times x. Here, it is the ratio of the distance between any two images to the distance between their pre-images which remains constant. And that constant is the absolute value of the coefficient of magnification C. For example, m sub 2, the doubling function, maps the origin into itself and 1 into 2. This is all we need to completely determine the magnification diagram. To obtain m sub 1/2, we map the origin into itself, 1 into 1/2, then x into 1/2 x. Thus, every interval shrinks to half its original length as it is mapped into the range. The negative function n matches every number with its additive inverse. N is simply a special case of magnification, namely m sub minus 1. Note that n also preserves distances. The absolute value function sends every positive number and 0 into itself, and maps every negative number into its additive inverse. Thus, though the domain is the entire real number line, the range of the function is restricted to the origin and its positive side. The absolute value function is the identity function on the positive side of the origin, and the negative function on the negative side. The inversion function sends every non-zero number into its reciprocal. As we map more and more points of this function, we see a peculiar property emerge. Each mapping line is tangent to an ellipse, which is itself tangent to the range and domain at the origins. The point 1 maps into itself, as does minus 1. If we reposition the domain and range lines so that they are exactly 2 units apart, then the mapping lines of the inversion function envelop a circle. Points that are close to the origin in the domain map into points which are remote from the origin in the range, while pre-images that are far from the origin in the domain have images close to the origin in the range. So far, so good. But now, what do we have here?